The jug of a blender is cleverer than you might think. Designers have spent years making innovative shapes that actually help blend food better.
It all starts here. We produce 435 jars in 8-hour shift, 1,300 jars a day.
Eduardo runs the huge plastic injection molding machine that makes the blender jars at this US factory. First, it heats plastic granules to melting point, 300 degrees Fahrenheit. Then it injects the liquid plastic into a highly polished metal mold.
The plastic gets injected right through the center of this side, and it comes out and it just, covers this area. And during that time, the material has the opportunity to get hard in there, so when the mold opens, the part is ready, to be taken out.
The most important thing about this jug is its shape. It has 5 sides.
1, 2, 3, 4, and this is the 5th side right here.
Engineers make the jug's shape irregular and put ridges inside to stop a whirlpool from forming. This forces more material down into the blades.
It helps stop that vortex, and it makes the food, anything that you're blending, blend better.
A clever jug is a good start, but it takes a lot of power to smash through nuts and solid ice. So under the hood sits a seriously souped-up electric motor. 68 metal plates welded together wrap around 300 feet of tightly wound copper. These work together to spin the rotor inside at 18,000 times a minute, faster than a jet engine. This drives the blade at a colossal 197 miles an hour. It takes a very special drive shaft to channel all that raw power from the motor to the blades.
On this machine, we run the drive shaft, which connects the blade that's in the jar onto the actual motor of the machine.
Ben runs the machines that make the most important metal parts.
It takes a raw piece of bar stock, and it'll go through and turn it down to the diameter that we need.
They carve the shafts out of toughened stainless steel.
So here we have the finished product of this machine. This here is the splines, and what it does is it connects onto this inner spline here, and it creates a really tight bond, and that gives us the extra strength we need to power our blade at the RPMs that we do.
The drive shaft passes up through the base of the detachable jug to the blades inside. So how come the jug doesn't spring a leak? Hidden inside, high-speed carbon steel bearings allow the drive shaft to spin at maximum speed. Around a second bearing, special Teflon washers make a low-friction seal between the jug and the spinning drive shaft. This means the blender can safely smash through nuts, ice, and liquid without spilling a drop. The seal is a precision part, so robots assemble it on a specially designed production line. They drill a hole in the base of the jug, then fit the bearings and seals. The blade, surprisingly, is completely blunt. With all that power from the motor, the blade doesn't need to slice through food and ice. It simply pulverizes it. On the final assembly line, workers put together the body of the blender by hand. Every fitting must withstand the intense vibrations caused by the motor.
Because of the power that goes through it, everything has to be super secure.
This highly skilled team assembles a blender body every 2 minutes.
So we put the armature in, and then we check the bearings and make sure nothing's clicking.
Finally, they give the whole thing a tough plastic housing.
And that's it.
This tiny hunk of pure processing power is a miniature hot rod on your worktop. It might not look mighty, but it's one of the most powerful machines